So in the first video, I stepped through the code and the basic functionality desired for this project. Now I'm going to run the executable and go through and show the actual operation of the program. The executable comes up, size to this window. It is compiled to run, so it is running right now. If you watch the task manager, you can see that the executable itself is not using very much at all. And I will now kind of go through this. So for instance, the speed pickup calibration, the turbine's full speed is 14,600. So if the technician was trying to simulate that with a frequency generator, depending on which probe he's looking at to simulate, you can get the frequency. This is a square wave frequency they would input to simulate that speed in the controller. They may have to calibrate or just verify things with that. If you want to determine certain milliamps or what milliamps should happen in a certain process, you would need to know the range that the instrument's set calibrated for in the first place. But let's say 0 to 400 degrees, and we wanted to know how many milliamps 100 degrees is, and you would know that it should be 8 milliamps. So you could simulate that with a simulator or just verify operation. And in the reverse direction, if you're measuring milliamps in the field and you want to know what process value that would be, you can enter that here. Platinum 100 RTD resistance versus temperature. Platinum 100 is 100 ohms at 0C, so that's where we're at here. And if they wanted to check an instrument that's in ambient, say 78 degrees, then they should be getting about 110 ohms for a properly functioning RTD. The mechanical tab, this is just a holder for now. The technicians are still working on a list of what's important for them to have in here, but here's a few. So the fuel nozzle bolts for the gas turbine they work on is 85 inch-pounds. Thermocouples, 65 inch-pounds. Liner supports 85. They can just select from there. Emissions tabs, if they were measuring stack emissions out of the gas turbine, let's say they got 40 NOx and 15 CO. See, if with 0% oxygen, that would be pretty small corrected values. If we are actually at 15%, then that would be the corrected values. And as you get more oxygen in your stack, those raw values would be reading low and correction would be a lot higher. They use this for tuning the boilers and tuning duct burners. Conversions are straightforward, already defaulted to values. Go through and type some numbers in. 27 inches of water column for a PSI, 27.7, based on the standards they use for temperature of the water. You can go back the other way. And standard cubic feet of gas to pounds an hour is a conversion needed when you're doing mass matching of, say, fuel to water for emissions control is based on a mass ratio, so they might have to do some conversions. 900 CFM gives you about 2478 pounds an hour of natural gas at the standard conditions discussed earlier, 14.73 pounds per cubic foot standard. And go back the other way. Show that. And finally, the last tab, the procedures. Again, a placeholder. There's 3 they've come up with that I've entered. They select it and just provides technical details that might easily be forgotten in the field, or if a newer operator needs to. Or here's a 24-volt flange and the torque pattern to properly torque it, and the steps taken. There's engine setting the tie bolt. It's a pretty in-depth procedure and pretty critical, as a turbine can rub and come apart if set wrong. So they've had some information here they would like. And the last one I have set up is just setting up for a calibration of a turbine vibration probe with the sine wave, 200 hertz, 1 volt peak to peak. That's basically the functionality here. The company likes this, and we will continue to add possibly tabs or more information for the existing tabs as we come up with useful items to put in here. Just want to thank you for your time, and goodbye.